Okay, so this video is going to cover how to do nomenclature for compounds. And the best way to figure out how to name these are, first you have to determine the type of compound. You have to decide if the compound's covalent, which are two nonmetals in a bond. The rest of them are typically ionic type compounds in that most of them have a metal in them. So if you have a metal present, such as you're going to have a metal with a multiple oxidation number. We talked about oxidation numbers, whether they're the plus or negative numbers that actually tell you how to put elements together in compounds. Some of the metals have only one oxidation number, so they're very easy to sort out what oxidation number to choose, but some of them have multiple, so you have to determine if the metal in the compound has just one oxidation number or if it has multiple, because there's a certain way you name multiple. Binary ionic, binary being two, ionic means there's a metal present. And then we have binary acid, so it's an acid, two elements. A metallic hydride, so we've got a metal bonded to a hydrogen. Ternary acid, so it's an acid, and ternary means we're going to be looking at least three elements or more, typically. Polyatomic, if you see three elements present or more, then you're going to be looking at a polyatomic ion chart to get the names. Hydrate means there are water molecules attached to the compound. Okay, so we're going to look at these compounds. We have some that are in a formula and you write the name, and then we have other ones that are in the name and you look up the element symbols and you write the formulas. Okay, so on your quiz tomorrow you're going to have one like this with the formula, you write the name, and then you're going to have one with the name and you write the formula. And so you're going to have two for each one: covalent, metallic hydride, metal with a multiple oxidation number, ternary acid, binary ionic, polyatomic, binary acid, and a hydrate. Okay, so the first set, we're going to look up P and Cl. Okay, so this is two elements, and we're going to look at the periodic chart. Okay, so you look at your periodic chart, and I told you in class, this right here, where the green is our metalloids, which they have characteristics of metals and nonmetals. And then you've got this bold black stairway. Okay, anything from this stairway all the way to the left side of the chart, bottom, okay, so the yellow area, and all up here, all of those are metals. So if you have any elements in the green and this area all the way to the left, those are considered metals. Okay, the nonmetals are only the blue, purple, and the dark purple. Okay, so we're going to look at these compounds. We've got phosphorus and chlorine. Phosphorus and chlorine. So phosphorus is here in the blue, that's a nonmetal. Chlorine here, nonmetal. So we have two nonmetals. A nonmetal with a nonmetal is a covalent compound. Okay, so the way you name a covalent compound, you've got a nonmetal with a nonmetal. You need to use the Greek prefixes, which are the numbers that go with the element symbols. Okay, so the way you would do that is you would say prefix and then the name of the first element, and then you would say a prefix, name of the second element, but then you would add the ending IDE. IDE means that's one element. Okay, as an example, so prefixes, we talked about prefixes. You need to know all 10 of those. 1 is mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. Okay, you're going to have to list those out, 1 through 10, tomorrow on your quiz. And so you need to really know those by heart. That should be 10 easy points for your quiz tomorrow. Okay, so now mono can be used. Sometimes they use it, sometimes they don't. They do it for emphasis. So I don't care if you choose to use it or you don't choose to use it. So this could be named two ways. It could be mono phosphorus, and then tri for 3 chloride. Okay, so it could be mono for 1, phosphorus, and then you would put trichloride, ending IDE. Okay, or you could put phosphorus trichloride. Okay, so covalent, you must have the prefixes. So let's look at this one. This is a capital I for iodine, capital O for oxygen, and on your chart, iodine is right here, nonmetal, oxygen, again, a nonmetal. So nonmetal, nonmetal, covalent compound. You must use Greek prefixes. So we're going to put 2, the prefix is di, and then that element is iodine. So di, iodine, name of the first element, and then we have 5, penta, penta, and then it's oxygen. But we're not going to put oxygen, we're going to end the ending with ide. So it would be pentoxide, pentoxide, ending IDE. Okay, now if you put pentaoxide, it's okay. When you're trying to name compounds, a lot of times they cut off extra vowels. So you would be perfectly fine if you put pentaoxide also, because the prefix is penta. Okay? Now, let's look over here. Easy thing is, you can see the prefixes, because these are nonmetals, nitrogen and oxygen. Okay, we know it's a single element at the end because it has IDE. Okay, so di, what we're going to do is write the formula for these. Di is 2. Nitrogen, our element symbol on our periodic chart is N. So you're going to have N2 for dinitrogen. And then pentoxide. So we have oxygen, and there's 5 of them. So we're going to put N2O5. Covalents are really easy because they give you the they give you the Greek prefixes. Tetra, 4. Hexa, okay, would be 6. So tetra, phosphorus. Looking on your periodic chart, phosphorus is a capital P. 4. Hex is a 6. Okay, and then we've got oxygen, so it's P4O6. Okay, real easy for covalents. Now let's move along to these. Look up the compounds. Okay, we've got Ca for calcium, Cl for chlorine. Okay, so 2 elements. We're looking on the chart, Ca, calcium. Calcium is a metal. As soon as you see a metal, you are not going to use Greek prefixes. Okay, other than a covalent, and later on a hydrate, which has a H2O water molecule on it, Those are the only two things that use Greek prefixes, covalent compounds and the water hydrate molecule. Okay, so since this is a metal, chlorine over to the right is a non-metal, looking on your chart. Okay, so you name these exactly like you would a covalent compound. The only difference is you are not going to say any Greek prefixes. So you don't have any di, tri, tetra, okay? So you say the name of the first element, calcium, and then it's chloride. Again, single element ide, ending ide. Calcium chloride. So even though there's two chlorine, we don't say di because it's ionic. As soon as you see a metal, no prefixes. Okay, so now this one has Ca3P2. So we have 3 and 2, but we don't say them. So name of first element, calcium. And then phosphorus, but we're going to put phosphide. Okay, phosphide. Changing the ending. Okay, now if you put phosphoride, that's okay. But they do cut off the extra syllables and make it phosphide to make it shorter. Okay, so element, ide, no Greek prefixes. Now this is very important. When we come over here and they tell us to write the formulas, this is where you need to look up the oxidation numbers because we don't know if it has 2 or 3 or 4 of something. Okay, I'm going to do a couple of these. So we have magnesium nitride. So magnesium right here, metal. So as soon as we see a metal, no Greek prefixes, so we know it doesn't tell us how many of each element, so we need to figure it out with oxidation numbers. Okay, so we're going to write the symbol for magnesium, which is capital M, lowercase g, and nitride, one element because it's IDE. The symbol for nitride is nitrogen, so it's a capital N. Now, tomorrow I'm going to give you a copy of an oxidation number chart. You'll also have a copy of your periodic chart, and you'll have a copy of the polyatomic ion charts, okay, that we've been using in the book. So you'll have that available for you. So I'm going to go ahead and turn to the oxidation number chart so we can look at magnesium and nitrogen. Okay. So here is our oxidation number chart. Magnesium, easy. It only has a +2. There's no other choice for magnesium but +2. So that really helps us out, figure out what it is. Okay, so above magnesium, I'm going to put a +2. So I can tell myself it's +2. Okay, way oxidation numbers work. In order for the compound to be neutral, okay, the oxidation numbers need to add together to equal 0 to basically balance out. So typically, if you have a positive on the left, almost always the metals on the left, there are some exceptions, but mostly on the left you're going to have positive. And so that means nitrogen has to be a negative. Okay, so magnesium only has a +2. But if you look at nitrogen, it has a +5, +3, +1, +4, +2, and a -3. So that's a lot of oxidation numbers to choose from. But since magnesium already is a plus, then we must choose the negative for nitrogen. And nitrogen is already has a -3. Okay, it only has a -3, only one negative. So that makes it easy. Now we've got +2, -3. If we added those together, that would give us a -1 left over. So it doesn't zero out or neutralize the compound. So what we do is we've got to increase the elements, okay, to match up to where they will balance out their charge to 0. Okay, so we look at common between 2 and 3. The easiest way to do it without even really thinking about it is you take this number, just the number, not the negative, okay, 3, and the book calls it crisscrossing. You take the 3 and you're going to give it to magnesium. And you take that 2, forget about the positive sign, And you're going to take that 2 and give it to nitrogen. So rewriting it, you're going to have magnesium. 3 goes down to magnesium. So that tells us there's 3 magnesium now. And then that 2 is coming down to nitrogen. So now we have Mg3N2. Now how does this balance out? Well, if one magnesium is a +2, 3 of them, 3 times +2 is going to be a +6. Okay, so now we have a +6 charge for magnesium. Now nitrogen, one nitrogen is a -3. But if we have 2 of them, 2 times -3, that gives you a -6. So we have -6 plus +6, and that makes it equal 0. So they neutralize each other, balance out to 0. So that's the oxidation numbers. But really, without even thinking about it, if you just take the numbers, figure out the oxidation numbers, crisscross them down, drop the charges, there should be no charges at the end, so it's Mg3N2. Okay, let's look at aluminum sulfide. So aluminum, symbol for aluminum right here, Al. Capital A, lowercase l, and then we have sulfide, okay, sulfur. So aluminum, easy again, only a +3. So we definitely know what aluminum is. Aluminum is a +3, so I'm going to put +3 here. So that means if it's a plus, sulfur needs to be a negative. So sulfur has 4 options, but only one -2. So we're going to choose the -2. So -2. So we have +3, -2. They don't cancel each other out. So we're going to do the crisscross. Okay, 2 is going to go to aluminum. And the 3 is going to go to sulfur. So we're going to rewrite it Al2 S3. So it's similar to magnesium and nitrogen up here. Okay? So that's how you do oxidation numbers for ionic. That's binary ionic. So no prefixes. So when we do the formulas, you have to balance them out with oxidation numbers. Okay? Now the next one is 1, 2, 3. We see at least 3 elements. As soon as you see at least 3 elements, you're going to need a chart. And in your book, it's page 191, but for your quiz, I'm going to have a copy of that for you. Okay? So you don't have to go through your book. So what happens? Most of the time, the first element is a metal. So if you see a metal, no prefixes, no mono, di, tri. Okay? The second part is almost always a polyatomic ion group. So rather than trying to figure out how to name nitrogen with 3 oxygen, what we do is we go look at that chart in your book. And so you're going to have a copy of that tomorrow. Okay? So periodic table, you're going to use the periodic table to name the first element. Okay? So let's go look up Ag in your periodic table. Okay, so we've got Ag right here, and it is silver. Silver. Okay? So we've got silver. So the first part is just silver. That's our metal. Now NO3, now we need to go and look up NO3 on our ion chart. Okay, so on page 191, here's your ion charts. This one up here typically has all oxygens in them. They're called oxy and ions. So they're negative ions as groups, and they have oxygen in them. Okay, each column has, for instance, this has 4 different compounds. So this one has, the difference is 4 oxygen, 3 oxygen, 2, 1 oxygen. So higher oxygens, lower. And if it has 4 of them, then it starts with per, ends with 8, and then this one just ends with 8. And then as they get smaller, their ending is ite, I-T-E, and then hypo, ite, ending. Okay, so some of them have 4 of them, some of them just have 1. Okay, so 1, and some of them have 2 or 3. Okay, so all you gotta do is look up that NO3. So let's find NO3. So we're gonna look, NO3 is right there. NO3, and it's a -1. Okay, when we're doing the balancing with oxidation numbers, you need to know that charge of NO3 is a -1. So this name is nitrate. Nitrate. So we have silver, and NO3's name is nitrate. That's all you're doing is looking up that compound group ion, and it tells you it's nitrate. Okay? So let's look at another one. Now this one is Na, single element. It's a metal. And then we've got NO2. So we need that group. Okay, if you look on your periodic chart for Na, that is sodium. Okay, and because it's a metal, no Greek prefix, so no monoditride. Now you look up the ion group NO2. You usually know it's an ion group because it's attached to an oxygen. Okay, almost all of them are attached to oxygen. So we're going to look up NO2. Earlier we looked up NO3, now we're looking up NO2. So NO2, if NO3 was here, well, NO2 is going to be right over here. So nitrite. So it has one less oxygen, so nitrate, nitrite. So this one's actually named nitrite. So just write what you see. Okay, all you got to do is look up on the chart. Okay, a couple of those we did. Now let's look over here. This one gives you the name, Potassium Dichromate. Potassium, if you look on your chart, it is a metal. So we definitely are not going to use any Greek prefixes, yet this one has a di in it. Okay, why does it have a di? Well, it's just the name of that compound. Okay, now, how do we know this is a polyatomic ion and not just a regular one element? Well, the indication is ATE. If we see the ending ATE or ITE, then you need to look on your polyatomic chart for the name. If it's IDE, it's only one element, so you just look on the periodic chart. Okay, so let's look potassium on your periodic chart. The symbol is K, and then we look up dichromate. Dichromate, so that whole word. So we're going to look through dichromate. So if we say bromate, okay, there it is, dichromate. Okay, so we're just going to write Cr2O7. And notice it has a 2 negative or a negative 2 charge for that group. So Cr2O7. So we're going to put potassium K, and then we'll put Cr2O7. Okay, now, because it is a metal in there, we don't have any Greek prefixes. So we need to figure out, is this balanced the way it is? So, looking back at your oxidation number chart, potassium, nice and easy. It's only a +1. Okay? So that makes it really easy. Potassium's a +1. But what is this Cr2O7 as a group? Okay? We looked at it just a minute ago, and it said it was a -2. -2. Okay, so -2. So what we're going to do is, it's a -2 as a group. So this whole group is a -2. Okay, now -2 + 1, they don't cancel each other out. So what do we need? We need this up to a +2. How do you do that? Well, if we double potassium, it's going to give a +2. So crisscross, give the 2 to potassium, and the 1, you don't have to write the 1, it's understood. Okay, we've already got a Cr2O7. Once you write that compound, it's already there. It's understood that it's 1. Okay, so we're going to rewrite this as K2 Cr2O7, and now it's balanced. Okay, let's look at the next one, zinc acetate. Zinc acetate. Okay, so zinc is a metal. Its symbol is Zn. Acetate, so that is an ion we need to look up on the chart. We know it's a polyatomic because the ending is 8, ATE. Okay, so we're going to go ahead and look up acetate. Now, looking through all these, can't find it. Where is it? Where is it? Okay, well, if it's not up here, then it's going to be down here. acetate is right here. Okay? C2H3O2. C2H3O2. Okay, so we're going to go ahead and C2H2O3. So C2H2O3. Okay, now as a group, it says it has a -1 charge. Okay, and if we look at zinc, zinc only has a +2, so it makes it really easy. +2. So this is definitely +2, -1. They don't cancel each other out. So if this is a +2, -1, we basically need to double this group. Double it. So what we're going to do is take that 2 and give it to this group. Crisscross it down. So what you do is, if it's a whole group, you got to put it in parentheses. And we're going to give that 2 over. Okay? That means we have 2 of these groups. So 2 times the -1 gives a -2. And we only need 1 zinc, which is a +2. So +2, -2. So it would be Zn, parentheses, C2H2O3, parentheses, 2 on the outside. That 2 shows we have 2 of those groups. And it balances out. Okay? So that is polyatomic. Now, the next one is down here, RHS. Okay, if we look up RH, that is rhodium, and it is a metal. We've already done metals, so we know no prefixes. The only difference is now we're looking at rhodium, and it has 3 oxidation numbers. Whereas before we were only looking at metals with 1 oxidation number. Really simple, we knew instantly what it was. But rhodium, well, which oxidation number is it? Is it +2, +3, +4? We don't know. Okay, so we got to figure out which one we're going to use. And the way we do that is we have to look at sulfur also. Well, sulfur has 4 oxidation numbers. It's got a +6, +4, +2, and a -2. But if we remember, one of them has to be positive, one of them has to be negative. Okay, well, rhodium only has positive oxidation numbers, so it has to be positive. So therefore, sulfur must be negative. So we look at sulfur and we see a -2, the only negative it has. So we know sulfur must be a -2. Okay, so it's a -2. Rhodium, okay, so the best choice for rhodium, well, it's got a +2, so that would be the easiest to choose, a +2, okay. Now the reason why we need to pay attention to this, because the metal has multiple oxidation numbers, so therefore when we write the name we have to indicate that it has more oxidation numbers, and then we have to indicate which one we chose, okay. If we chose the +2, +3, or +4, well, we chose the +2, okay. So what you're going to do is just write rhodium. So it is just like naming an ionic compound. Rhodium and the ending, sulfide. Okay, so 1 element ide. Just like you'd name calcium chloride. Well, rhodium sulfide. But calcium only has 1 oxidation number. Rhodium has 3. We chose the +2. Because we chose the +2, this is how you indicate it has a multiple oxidation. You're going to put a Roman numeral, and the Roman numeral stands for the oxidation number that we gave rhodium. So we chose the +2 because that balanced out a -2. So we put a Roman numeral 2. Now sulfur, if sulfur happened to be a -4, then we would choose the +4 for rhodium. And so therefore, we'd have a rhodium Roman numeral 4 sulfide. Okay, so what? Very easy, naming it just like we do the binary ionic, but except now because rhodium, a metal, has more than 1 oxidation number, we must show in the name which oxidation number we chose. Okay, so this was just a binary. Now this one is, okay, this is Cu, copper, and then it's I, capital I-O4. This is a polyatomic. Okay, polyatomic, if we look at copper, Cu, multiple oxidation, so it has 2. So we're going to have to put a Roman numeral in there because it has to. Okay, so we're going to do the name of copper and polyatomic. So we're going to need to look up on that chart IO4. IO4. So on this polyatomic chart, we look up IO4. It is right here. It is called periodate. Periodate. And it has a -1 as a charge. So IO4 is periodate. So we have copper, periodate. Okay? Now, copper, let's look at the oxidation numbers. Periodate's a -1. So we know it's a -1 as a group. So we need to balance out copper with periodate, which means we indicate